Hello everyone, this is VIJAY, Math faculty. Heartily welcome to my channel, Vedic Brilliant Math Educator. Today we are going to discuss a new chapter, very interesting chapter, Progressions. It is the 6th chapter of class 10. In this chapter Progressions, we will learn more about arithmetic progressions, nth term of an arithmetic progression, and sum to n terms of an arithmetic progression, geometric progression, and also we will focus on nth term of geometric progression. This chapter Progressions, you may get one long answer type question, one short question, one very short question, 2 or 3 multiple choice questions. Dear viewers, keep on watching, don't skip the video till the end. That will definitely helpful for you. If you are watching first time of my channel, please subscribe the channel and try to share this video to your friends and family members as much as possible. If you did not watch the previous video, then do watch the previous video by clicking this I button as well as go with playlist also. Let us see what are learning outcomes of this chapter Progressions. So first one, it is Introduction to Progressions and general form of an arithmetic progression, sum of n terms of an arithmetic progression, next it is geometric progression, and last one, nth term of geometric progression. So we will focus on these concepts. In this chapter we will focus on these concepts. So let us see what is Introduction to Progressions. Before going to our topic Progressions, we will learn some concepts, that is sequence. So what is sequence? A sequence is a list of numbers written in a particular order. So for example, I am taking 1, 3, 5, 7, 9, so on. 1, 3, 5, 7, so on. So here the sequence of the numbers are odd numbers. Here I took here these all are odd numbers. So one particular rule, one particular order it is there, that is the order of odd numbers. One more I am taking the example 1, 4, 9, 16, 25, 36, so on. 1, 4, 9, 16, 25 and 36. This is a sequence of square numbers. So here we can take, this is the 1 square means 1, and this 4 we can take 2 square, 9 we can take 3 square, and 16 we can take 4 square, and 25 5 square, 36 6 square. So here this all are square numbers. 1, 4, 9, 16, 25, so on are called sequence of square numbers. Next, one more I am taking, one more example, 1, minus 1, 1, minus 1, 1, minus 1, so on. 1, minus 1, 1, minus 1, 1, minus 1. Here it is the sequence of numbers 1 and minus 1 repeating numbers. The numbers alternate numbers. So alternate numbers between 1 and minus 1. So 1 minus 1, 1 minus 1. Alternate, it is repeating, that is. This is called sequence. What is sequence? A sequence is a list of numbers written in a particular rule. Particular rule is called sequence. Now we will go to series. What is series? Series means a series is a sum of the terms of the sequence. Series is a sum of the terms. Sum we need to take. The sum of the terms of a sequence is called series. For example, here we took, this is the first example, this is the second example, this is the third example. So first example series, how we have to take 1 plus 3 plus 5 plus 7 plus 9 plus, so on. So series means we need to take the sum, we have to take that given terms one, we need to take the sum. Sum means addition we have to take, that is called series. So what is series? Series is a sum of terms in a sequence or list of numbers. Sum of sequence or list of numbers, sum we have to take, that is called series. Now our topic, that is progression. So what is progression? A sequence or list of numbers following some specific rule is called progression. It is following some specific rule is called progression. For example, 2, 4, 6, 8, so on. So here we are adding to second number except the first number. So 2 we are getting the third. Second number we are getting. Here third number how we have to get? Adding 2 to second number, that we are getting third number. So fixed term we are adding, that is progression. One more thing I am taking. Here one more example, 10, 20, 30, 40, so on. Here also it is following some rule. Every number added by 10. Every number is added by 10. So for except the first term we have to take. So here 10, 10 plus 10 only 20 we are getting. 10 plus 20 only, that is 30. 10 plus 30 only 40. 10 plus 40 we can get next number. 10 plus next number, that like that we have to get. This is called progression. So what is progression? A sequence or list of number following some specific rule is called progression. So here term, it is terms are there. Terms. What is term means? Each of the number in a list of numbers or series is called terms. For example, here we took the 2, 4, 6, 8. This example I am taking 2, 4, 6, 8. So here what we have to say, this term. This is the 2 is the first term. This is 2. And 4 we can take as a second term. Second term, this is 4. And third term, that is here it is 6. Fourth term, that is 8. So here first term we are denoting as first term, here we took as first term in the list of numbers. What is the first term? That is called first term. In the list of numbers, second number is called second term. And list of numbers, third term is called third term. Third number is called third term. So here this first term we are denoting as A1 or A we have to denote. A1 or A. Second term we are denoting as A2. And third term we are denoting as A3. And fourth term we are denoting as A4. This is about the terms. So types of progressions. Now we will discuss types of progressions. Types of progressions. In this first one, arithmetic progression, and geometric progression, and third one, harmonic progression. But in our topic, in the 10th class level, only we have arithmetic progression and geometric progression only we have. So it is harmonic progression in higher studies. Now we will discuss arithmetic progression. What is arithmetic progression? Arithmetic progression. What is arithmetic progression? An arithmetic progression is a list of numbers in which the number obtained by adding or subtracting a fixed number to the preceding term is called arithmetic progression. So, what is arithmetic progression? An arithmetic progression is a list of numbers in which the term obtained by adding or subtracting, while adding or subtracting by a fixed number to the preceding term is called arithmetic progression. So here except the first term, except the first term, remaining terms we need to add or subtract, we can get the next numbers. So example 10, 20, 30, 40, 50. So here except the first term we can add some number, we are adding, we can get next number. How much we can add here? 10, 20 it is there. So we need to add plus 10 to first number, we are getting the second number. So here third number how we have to get? Second number to this fixed number we need to add. Means plus 10 we need to take 20 plus 10 we can get the third number, that is 30. Fourth number how we have to get? Again we are adding the fixed number to the preceding term. Preceding means this term. So you can add plus 10. 30 plus 10 that is 40. Remaining terms also like that only we are getting. Now one more example. Here 1, 4, 7, 10, 13, so on. So here once you can observe here, except the first term, second term how we have to get? We can add one number, any one number. Which number we need to add? We can get 4. 1, 2 we can add 3, we are getting 4. 1 plus 3 that is 4. Second term we got it. Third term how we have to get? For second term too you can add again fixed term, that is 3. 4 plus 3 that is 7. Then we got the third term. Next fourth term also we can add some fixed number, that is 3. Plus 3 we are adding. So 7 plus 3 that is 10. Again we can add 10 plus 3 that is 13 we are getting. So this is adding one. Subtracting also we can get like that only. Now here we are adding this fixed term, we are adding here 3, here 3, here 3, and here also we are getting 3. Here we added 10, here 10, here 10 like this. So the fixed term we have to say the common difference. So what we have to say? Common difference. Common difference how we have to get? So the difference between any two successive numbers we can take. Successive means serial numbers we need to take. So for example here list of numbers like this it is there: A1, A2, A3, A4, A5, so on it is. Means common difference we are denoting as D equal A2 minus A1. First two terms in A2 minus A1, successive terms. No, I need to take this both. Okay, you can take A4 minus A3 we can get, that is also common difference. So what we are adding the fixed term, that is called common difference. So what is an arithmetic progression? Once again repeating. An arithmetic progression is a list of numbers in which the term is obtained by adding or subtracting the fixed term to the preceding term except the first term is called arithmetic progression. Next, general form of an arithmetic progression. General form of an arithmetic progression. So what is the general form of an arithmetic progression? So the general form of an arithmetic progression is A comma A plus D. Here what is D? So A plus D means first term to we need to add the common difference. Fixed number we are adding. That common difference we have to say the fixed number is called common difference. That adding only we are getting the next term. Next, a plus 2d. This is the third term. A plus 3d. So on. Plus, comma. A plus n minus 1 into d is called general form of an arithmetic progression. So what is the general form of an arithmetic progression? A comma, a plus d comma, a plus 2d comma, a plus 3d comma, so on. A plus n minus 1 into d is called the general form of an arithmetic progression. Here a means first term, d means common difference. Now next one it is finite arithmetic progression. Finite AP. So finite AP, finite means we know that is the number of terms of an AP is finite, then it is called finite AP. Finite means which we can count, that is called finite. Infinite means which we cannot count the number of terms in that AP, that is called infinite AP. So which we can count the number of terms in the AP is called finite AP. So for example, 3, 4, 5, 6, 7. So we can count in this. How many terms are there? 1, 2, 3, 4, 5. 5 terms. We counted and we said that is which we can count, that is called finite AP. Next, infinite AP. Infinite means which we cannot count the number of terms of an AP is called infinite AP. Example 10, 20, 30, 40, 50, 60, so on it is. So how many, what is the ending term? We don't know. How many terms are there? We don't know. So like this one we can say the infinite AP. For example, one more example. 1, 2, 3, 4, 5, 6, so on. Means we cannot count the number of terms in these terms, that is called infinite AP. Next one it is nth term of an AP. It is very important. Nth term of an AP. AP means arithmetic progression. Nth term of an AP. We need to find the nth term of arithmetic progression we have to find. So here A is called first term and D's we can taking as a common difference. Already we discussed this is common difference. So in a list of numbers, first term, what is the first term? The general form in what is the first term? A comma, A plus D comma, A plus 2D, like that we took now. So here we can take like that only. So first term equal A1. A1 or A. A1 or A. Second term, that is A2. A2 how we have to get? First term to we need to add the fixed term. Fixed term means that is D. A plus D. That equal A plus D only we can get. Next, third term, that is we are denoting as A3. A3 how we have to get? For second term to we need to add the fixed term. What is second term here? A2 is the second term. Fixed term is D. So here A2 means already we got it here. A plus D plus D. That implies A plus D plus D, that is 2D. Now fourth term we are taking as A4. A4 how we have to get? Preceding term plus D. Preceding term what is here? A3. A3 plus common difference. So what is A3? A3 value just normally we got it, that is A plus 2D plus D is as it is. That implies now fifth term, that is we are denoting as A5. So fifth term A5 equal to A5 how we have to get? That preceding term plus fixed term. Preceding term it is A4 plus common difference. Fixed term is common difference, that is D. That implies A4 value just normally we got it A plus 3D plus D, that equal A plus 3D plus D, that is 4D. Just once you have to observe here, first term means A, second term A plus D, third term A plus 2D, third means A plus 2D, fourth term A plus 3D, fourth term means A plus 3D, fifth term means A plus 4D. Here 5 means A plus 4D. What about the sixth term? This total, no need to take the generalization, this total. A6 equal, directly we can write. How we have to write it? A plus, here fifth term means we are getting here 4 we are getting. Here sixth term means we can get here 5D we can get. So on. Now I need nth term. So nth term An we are denoting equal to, here sixth term means you written 1 less you written here, means A plus 6 minus 1 into D, that is 5D we are getting. Fifth term means you written A plus 4D. 4D how we have to get? 5 minus 1, that is 4 we are getting. Same as this way here. Nth term means A plus n minus 1 into D we can take. This is called nth term of an arithmetic progression. So what is the nth term of an arithmetic progression? An equal A plus n minus 1 into D is the nth term of an arithmetic progression. This is very useful formula. So every time we are using this is. So what is the nth term of an AP? An equal A plus n minus 1 into D is called nth term of an AP. Next one, it is sum of n terms of an AP. Sum of n terms of an AP. So we know the general form of an AP. What is the general form of an AP? That is S. A comma, A plus D comma, A plus 2D comma, A plus 3D, so on. A plus n minus 1 into D is called general form of an AP. Same that one I am taking here now. General form of an AP. This we are denoting as An, we are denoting A comma, A plus D comma, so on. Otherwise one more we have to write it. A plus 2D comma, so on. A plus n minus 1 into D. Now we need to take here sum of n terms of an AP. Sum we need to take, sum of n terms. Sum of n terms of an AP. Sum of n terms of an AP. So this is we are denoting as Sn we are denoting. Here I am writing A plus D plus A plus 2D plus so on plus A plus n minus 1 into D. This is Sn. Again we need to write that reverse order we have to write. Once you can write in reverse order. So reverse order means here it is A plus n minus 1 into D we are getting. This is the first term. Here this before term what we have to get? A plus n minus 2 into d we are getting. This before term a plus n minus 3 into d. A plus n minus 3 into d plus so on. Last term means here we can take as a first term. This both we can add plus all we have to take the plus. Sn plus Sn, that is 2Sn equal a plus, up to here it is the first term, a plus n minus 1 into d plus here this is the up to here it is second term, means a plus d plus a plus n minus 2 into d plus so on. I am taking this one, I am not taking, last term I am taking now, a plus n minus 1 into d plus a, this is the last term. Now 2Sn equal a plus a, that is 2a plus n minus 1 into d as it is plus a plus a, that is 2a plus d plus n into d nd minus 2 into d 2d plus so on plus a plus a, that is 2a plus n minus 1 into d, here as it is we need to take. So here 2Sn equal 2a plus n minus 1 into d as it is plus 2a plus d as it is. Here this is the nd I written, this is plus 1d, this is minus 2d. So 2d's2 we need to take one subtraction, we can get minus d plus so on plus 2a plus n minus 1 into d. Now 2Sn equal 2a plus n minus 1 into d plus 2a plus, here d we need to take as a common, so n minus 1 into d plus so on 2a plus n minus 1 into d. Now here 2Sn equal here this is the 2a plus n minus 1 into d plus 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 2a plus n minus 1 into d. How many times it is repeated? How many times it is repeated? N times it is repeated, means we need to take n into 2a plus n minus 1 into d we need to take. So here I am writing this 2 I am transposing, Sn equal n by 2 of 2a plus n minus 1 into d is the sum to in terms of an AP. So Sn equal n by 2 of 2a plus n minus 1 into d is the sum of n terms of an AP. This is about the introduction of the progressions. In the next video, we will focus on the given situations are arithmetic progressions or not. Please support me by subscribing my channel Vedic Brilliant Math Educator. Like and comment on this topic. Dear students and viewers, do you like this video? Please share. It will helpful for others also. This is VIJAY signing out. Thank you. Thank you very much.